Time magazine called him the unsung hero behind the internet. CNN called him a father of the internet. President Bill Clinton called him one of the great minds of the information age. He has been voted history's greatest scientist of African descent. He is Philip Emeagwali. He's coming to Trinidad and Tobago to launch the 2008 Kwame Ture lecture series on Sunday, June 8th at the JFK Auditorium, UWI St. Augustine, 5 p.m. The Emancipation Support Committee invites you to come and hear this inspirational mind address the theme, crossing new frontiers to conquer today's challenges. This lecture is one you cannot afford to miss. Admission is free, so be there on Sunday, June 8th, 5 p.m. at the JFK Auditorium, UWI St. Augustine.
I'm Philip Emeagwali. I am the subject of school reports because I invented a new supercomputer that was the precursor to the modern supercomputer. I invented a new supercomputer that is a small copy of a new internet. The new internet that I invented is defined and outlined by an ensemble of 65,536 commodity off-the-shelf processors that are identical to each other and that are equal distances afar and apart from each other. That new internet is complex, abstract, and a mystery. The 65,536 processors of my new internet were married together by 1,048,576 bidirectional email wires and married together as a new supercomputer and computed cohesively and did so as one new integrated supercomputer and computed seamlessly as one new internet. My 64 binary thousand processors that outlined my new internet communicated via emails and did so with a complexity that I cannot completely describe in words alone. Nor can I completely describe my processor-to-processor email exchanges and completely describe them as equations on a blackboard alone, or completely describe them as algorithms on a motherboard alone. I began supercomputing at age 19 on June 20, 1974 in Corvallis, Oregon, United States. I was the lone wolf and the only full-time programmer of the fastest supercomputer of the 1980s. Today, the fastest supercomputer costs the budget of a small nation. The fastest supercomputer is programmed by thousands of supercomputer scientists. The fastest supercomputer occupies the space of a soccer field. The holy grail of the fastest possible supercomputer is to marry together all the processors in the world and marry them to all the computers in the world and marry them to all the supercomputers in the world and marry processors and computers and supercomputers together and as a never before seen internet that will become a never before seen planetary sized supercomputer that will turn our science fiction to our descendants non-fiction. I'm Philip Emeagwali. I am the massively parallel processing supercomputer scientist that conducted research alone. I am the massively parallel processing supercomputer scientist that conducted research alone and conducted it from the age of 19 in Corvallis, Oregon, United States, to the age of 35 in Los Alamos, New Mexico, United States. To the supercomputer scientist, Los Alamos, New Mexico is the capital of supercomputing. Prior to my experimental discovery of the massively parallel processing supercomputer that occurred on the 4th of July of 1989, it was said that parallel processing is a beautiful theory that lacked experimental confirmation. Prior to the 4th of July of 1989, I was the unknown supercomputer scientist who told his massively parallel processing supercomputer story alone and told it to no supercomputer scientist in particular. In fact, my 1057-page report that I distributed to vector processing supercomputer scientists of the 1980s and that described my new supercomputer was at first thrown into the trash. After my experimental discovery of the massively parallel processing supercomputer that occurred on the 4th of July of 1989, I became a known supercomputer scientist, and those that threw my 1057-page report into the trash wanted to become my new best friend and clamored to retell the story of how I experimentally discovered the massively parallel processing supercomputer that is a new internet. As I became more known, I discovered that many insidious voices were clamoring to retell my story and to retell it in their visions rather than in my original vision. I discovered that there are 1,000 secondary voices can drown my primary voice. I discovered that the story of my new supercomputer, that is not a computer per se, but that is a new internet de facto, was reduced to a cacophony of secondary voices. I want to redeem my story and reclaim my voice and make my voice the loudest voice in the world of the modern supercomputer, and make my voice to be continuously heard, to be the most continuously heard voice in the history of the internet. Each of my processor within my ensemble of 65,536 processors had its unique name, that's also its unique email address, that's 16 bits long. I used a binary reflected code to generate my 64 binary 1,000 unique names that were each a unique string of 16 zeros and ones. With the binary reflected internet naming scheme that I used, if two email addresses differ by only 1 bit, then the processors that corresponded to those two email addresses differ by only 1 bit. And those two processors were directly connected. That connection allows nearest neighbor email communications that maximizes the speed I could attain while executing my floating point arithmetical operations. My 64 binary 1,000 emails traveled across 1 binary million or 1,048,576 bidirectional email wires. I had theorized that speed increase of a factor of 64 binary thousand, and therefore I was expecting to experimentally discover the world's fastest speed in computation. Even though I was expecting the world's fastest speed in computation in 1989, I was shocked and in disbelief when the world's fastest speed in computation popped up on the computer monitor of my four-brained workstation that front-ended my 64 binary thousand-brained massively parallel processing machine. Even though my experimental discovery matched my companion theoretical discovery that preceded it a decade earlier, I developed an imposter syndrome. I developed it in part because I was black and African. I developed an imposter syndrome because I was ostracized and only one white computational scientist attended the first lecture of massively parallel processing that I gave in November 1982 in Washington, D.C. Because I developed an imposter syndrome, I convinced myself that I made a mistake. Due to self-doubt, I wasted half a year, the last half of 1989, searching for the mistake in my new massively parallel processing supercomputer code that did not exist. My eureka moment felt like a jolt of electricity. I screamed loud for others to hear. Ewo! 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 I screamed in my ancestral Igbo language of Onitsha, Anambra, the former East Central state of Nigeria, West Africa. On the 4th of July of 1989, I experimentally recorded a world record computational speed of 20,000 calculations per second. Then my screaming continued for half a year, with each small increment that led to a new world record. My computational speed peaked at 47,303 calculations per second for each processor that I massively parallel processed through. My supercomputer speed that made the news headlines in 1989 was achieved in a high-level programming language. I discovered that my new massively parallel processing supercomputer could compute 4 times faster if I had computed with a low-level programming language that could have enabled me to use an assembly-coded routine and use it to reduce the execution time of my most computation-intensive kernels. The supercomputing world record that I recorded in high-level programming language and recorded in 1989 totaled 3.1 billion calculations per second across my parallel processing machine that was my new internet. That fastest computation was recorded across a new internet that's a global network of 65,536 processors that's de facto a massively parallel processing supercomputer. The eternal quest of humanity for faster computing aids that began with the abacus in ancient China remains the holy grail of computing. Yet, that quest for had only one paradigm shift. I paradigm shifted from computing within only one computer that was powered by only one processor to supercomputing across a new internet that is a global network of 64 binary thousand processors, or supercomputing across a global network of as many computers, or supercomputing across a new internet that computes by massively parallel processing. In the 1970s and 80s, the grand challenge of communicating across that new internet was ridiculed and mocked as follows: parallel processing, or supercomputing many things at once instead of computing only one thing at a time, is a beautiful theory that lacks an experimental confirmation. The June 20, 1990 issue of the Wall Street Journal mentioned that I, Philip Emeagwali, experimentally discovered how to massively parallel process and how to simulate the multi-phase subterranean motions of oil, water, and natural gas flowing a mile deep inside an oil field, and how to simulate the production reservoir by dividing the oil field into 65,536 equal parts that I emailed to 65,536 processors. That experimental discovery was also the cover story of the May 1990 issue of the Siam News, the flagship publication of record of the research mathematics community that was published by the Society for Industrial and Applied Mathematics, and that was written by research mathematicians and written for research mathematicians. My first newsworthy speed-up result that occurred on the 4th of July of 1989 was a quantum leap in supercomputer performance. It was either a zero speed-up or a 65,536-fold speed-up. There was no speed-up between 0 and 64 binary thousand. I recorded a 65,536-fold increase in both the speeds of email communication and arithmetical computation. I experimentally discovered the fastest supercomputer when I experimentally discovered the fastest supercomputations and discovered them across my hyper-global network of 65,536 processors. My network, networked processors, or as many computers around a hyperglobe with 1,048,576 bidirectional email wires. A world record speed in arithmetical computation and email communication. A world record speed in arithmetical computation and email communication puts a man and his machine inside the terra incognita that is the magic zone of the supercomputer and the new internet. It hits the sole programmer of all those 65,536 processors as a jolt of electricity. Right away, my few confidants said I will be famous. The paradigm-shifting technology named the massively parallel processing supercomputer that I experimentally discovered changed the way we do the most computation-intensive arithmetic on the modern supercomputer. The supercomputing paradigm shifted away from executing floating-point arithmetical operations that arose from extreme-scale algebra and shifted away from executing those operations in the singular. The supercomputing paradigm shifted to dividing the computation-intensive initial boundary value problem into 65,536 subsets of arithmetical problems that were equal to each other and that were equal in terms of total floating-point arithmetical operations count, and sending those 65,536 email messages that each contained a subset of arithmetical problems, and following each email with floating point arithmetical computations that solves the companion initial boundary value problem, and most importantly, executing the computation and the communication in the plural senses. I realized the profound and the paradigm-shifting meaning of that never-before recorded 65,536-fold increase in speed. A grand challenge problem that took 65,536 days or 180 years to solve will now take only 1 day to solve. That experimental discovery opened the door to today's world of massively parallel processing supercomputing, in which a grand challenge problem that takes 30,000 years to solve on one processor will now take only 1 day to solve across 10,649,600 commodity off-the-shelf processors that is at the core of a massively parallel processing supercomputer. For those still enmeshed in the old paradigm of sequential computing, their 30,000 years of sequential computer work is merely 1 day in my new paradigm of massively parallel supercomputing. I discovered the paradigm in which the boundary between the computer and the internet is blurred.
Insightful and brilliant lecture.